it just looks very dirty. And I cannot stop moving if I sit on this. I'll probably be busy.
Given you is the extra credit. You should be able to do it after the lecture today. So if you finish the extra credit and you turn it in on the test day, which is March 6th, no, March 4th, then you have 2 points added to your second test, okay? Alright, let's take a look at our schedule. So everybody received assignment number 4 already, right? So if you have not, just let me know, okay? See me after class and you get assignment number 4. And so today is the last day to submit assignment number 3. So if you have not done it, just go ahead and turn it in over there. I'll grade it, okay? Let me see, test number 2 on Wednesday, March 4. So we have maybe 1 or 2 weeks. We do have a lot of time. But try, if you already finished assignment number 3, you try to finish number 4 as soon as possible. Because if I take a look at assignment number 4, on the first question, it's about revenue function, cost function. Yeah, we already talked about that. You should be able to do it. Okay. On the second question, it's a piecewise function. We also talked about piecewise function. We learned how to graph piecewise function already. For number 3, I think there are 4 parts, A, B, C, D. You should be able to do part C and D after the lecture today. So part C, they ask you to find domain and range. Okay, domain is all the x value. You look at the graph and try to find all the x value and make the function define. And range, you look at a graph and you look at the y and see all the y value to make the function define. That's with the range. Increasing and decreasing, hopefully we have time to go over today, okay? That's for number 3. And number 4, we talk about even and odd. I don't know, last time we talked about even and odd yet? No. We talk a little bit about that. We haven't done any example. We're going to do some example today, okay? Then you should be able to do even and odd. And by the end of next week, I think you can do all of the problem in the assignment. Okay? And again, you guys have to do assignment, okay? There's no other choice. Try to get help from the master. I know the last assignment is kind of, I don't know how you guys feel. I received some email that they find a hard time doing assignment number 3. But I said that all you need is just a slope-intercept form, parallel property, perpendicular property, point-slope form. That's all you need. Okay? So I think if you go to the math center, they should be able to figure out that for you. Okay? Any other questions?
So this one that assignment 4 is due.
Oh, I give you extension. Let me see. Good. Good question, because I gave you another class extension. So over here, according to the schedule, it's due February 26th. But how about turning it in on the test day? How about turning it on the test day? But remember, you see that if you're turning it on the test day, and then you have assignment number 5 on March 18, and between them we have spring break. And spring break starts from it's the week between 9 and 11. So with spring break, Valencia closed, and you cannot go to the math center, and you won't be able to get help. Okay, so maybe next week I'm gonna give you assignment number 5. I just print it out and give it to you. Okay. So try to finish assignment number 4 as soon as you can. Okay. Don't wait until the end. I give you an extension into the test day, but don't wait until the end. Yes.
You said the test day is March 4th?
March 4.
Okay.
Yes. Wednesday, March 4. Okay. So today is 19, right? So we have. Oh, we don't have a lot of time, guys. Yeah, we have only a week, more than a week. So about 10 days. So you see that? So try to finish assignment number 4, okay? Well, just consider it as a review. You work on the problem, this help you to do the test, okay? I'm going to send you sample test number 2 on Monday. On Monday. So you have a lot of things to review, and a lot of practice for you to do. If you guys have any questions, just let me know. Okay. Any other questions? Good. Great. All right. Let's continue with our function. So last time we talked a little bit. We touched a little bit about even and odd function, and I say that. I remember I said that if it's an even function, then the condition for the even function is f of negative x equal to fx. That is the condition you use to check if the function is even or not. Okay? And if the function is even, we know that. Sorry about that. If a function is even, we know that its graph will be symmetric about our y-axis. Symmetric about y-axis. And the typical example of the function that has a graph that's symmetric about the y-axis is the square function. If I just go ahead and graph, we sketch a square function. So this looks like this. This is a square function. And you see that it's symmetric about the y-axis. No matter how you reflect this curve about the y-axis, it gives you the same thing. Just imagine you flip it over here or you flip it over there, it gives you the same thing. Or you can say if I pick a point here and I reflect that point over the y-axis, I have another point here. Okay? And the distance from here to here is the same. So my graph is not really perfect, but it's okay. Okay? And the same thing for any point on this graph. Okay? So if I reflect the point A here, then it gives you a graph. Okay? If I reflect point B here about the y-axis, it gives you B graph. Then I say that this curve is symmetric about the y-axis. Of course, there's a lot of functions that's symmetric about the y-axis. That's why we say there's a lot of function that is even function. Okay? However, some function is very hard for you to visualize, for you to graph. Even you put it into the calculator, you graph it, and you observe the graph, and you see that, oh, maybe it is symmetric about the y-axis. Okay? But sometimes it's very hard for you to graph. Okay? Sometimes the calculator cannot graph the whole thing. Okay? So if you're in that situation, then in order to check if a function is even function, we have to use this condition. And I'm going to give you another example. This is example 2. Example 1, this is 2. And I give you the function f of x. That is very hard to graph unless you use calculator. But I want you to check if the function is even or not. Okay? I have something like this. Negative x to the 4 plus 5 absolute of x. Okay. And I want to know if this function here is even or not. Okay? Okay. So this is a very typical example of what I have on the text. Okay? I'm going to give you the function and ask you, okay, if this function is even or odd. Okay? Of course, you're not going to go ahead and graph it and give me the answer. You jump into right into the conclusion and you say that, oh, this is even or this is odd, without any explanation. Then you won't have any credit for it. Okay? So in order to do this, you're going to apply this condition. Okay? So the first step you have to do is you always start with f equal to negative x. Okay, so if you look at this, I don't know, remind you of something. When you try to evaluate a function at a certain value, what you usually do? For example, if I ask you to evaluate a function at x equal 2, what do you
Put
do?
the 2.
And you put 2 in. You put 2 in there. So in order to do this, this is like you evaluate a function f at negative x. So I put negative x into the x. How we do that? Alright, it's easy. So negative 2, I keep it there. Okay. Instead of writing x, I throw away my x. Okay? And I'm gonna put negative x in. So I use different color so that you can see. Okay, I put negative x in. Number 4 is still there because it's the exponent. That's a power number there. Okay, plus. Okay, absolute still there. Okay, I haven't changed anything. I throw away this x and I put negative x in. Okay, everybody see that? Basically, I just throw away the x and put the negative x in. Okay, it's like you evaluate a function at a certain value. Okay, now, in order for you to know it's an even function, you need to get something equal to fx. Okay, and how do I know that it's equal to fx? Well, let's expand them out. Okay, expand them out. Negative 2 still there. Negative x raised to the 4th power give you what?
X to the
X to the
4th.
x to the 4th. Because negative raised to the 4 is just positive. X to the 4th. Okay. Plus 5. Okay. Absolute of negative x give you
X.
Plus minus. Square root of
X.
absolute of negative is a positive. But the x we don't know the value. So absolute of negative x is still absolute of x. Okay, still absolute of x. Because we don't know the x. If we know x is x is 5, then we know absolute of 5 is 5. But right now we don't know the x value. Okay? Alright. So after you expand them out, after you simplify some way somehow, then do you think that this is the same as this? Yes. So if it's the same as the original, after you replace the x with negative x, then I can conclude this is even. If it is the same, then it's even. Okay. Everybody clear? Okay. So on my extra credit, I asked you to check if it is even or odd, right? Then you have to do this step. Any question on even function? Okay. Then let's continue with our odd function. Let's do the odd function. And last time I always notice I also said that for our function, the condition is f of negative x equal to a negative f. That is for our function. And if a function is odd, then its graph is not symmetric about the y-axis anymore, but it's symmetric about the origin. It's symmetric about origin. Example. I give you a simple function that's symmetric about the origin that you already learned, but maybe you don't notice it. I have a function that has the graph look like this. Anyone remember what function this graph represents?
Cube, right?
What's that?
Cube.
Cubic function. Not cube root, okay? Cubic function. Okay, so you see this is one of the parents' functions I already provided last week. And you're supposed to memorize all of this. So this is cubic function. And I'm going to pick a point on one of the branch here. Okay, I call it point A. Okay. And I mirror this point about the origin, and it gives me another point. This is origin. It gives me another point, I call it point A prime. Okay. And because this is an odd function, and because this is symmetric about the origin, so the distance between the origin and point A prime and A is congruent. Okay. So if you pick a point and you mirror that over the about the origin, okay, you get another prime, and the distance is equal distance from the origin, then you know that that function is symmetric about origin. And you know you can conclude that it's an odd function. Okay. Of course, it's very hard for you to see by just visualize the graph in your brain, you know, or even by graph the whole function. Some function is very hard for you to graph, and it's very hard for you to check if it's symmetric about the origin or not by looking at the graph only. No, it's very hard. Okay, because I'll give you a simple function. Then that's why it's kind of easy for you to see the distance from here to here is the same. You know, if I give you like a more complicated function, something like not parent function, because this is parent function, then again you have to use this condition. Okay, so on the second example, okay, I give you the function, and I want you to check that function is odd or not. I have something like this. Fx equal to 4x to the third power minus x. Okay, the question is, check if Fx is odd or not. Let's see. Let's see how we do this. And this is matter, if you want to check it even or odd, you always start with f of negative x. Okay? You always start with f of negative x. So I'm going to start with f of negative x. And I do the same as, we do the same as we evaluate the function at a certain value. I replace my x with negative x. So I throw away the x here. See, we have 2x. I throw away this 2x, and I replace this 2x with my negative x. But number 4 is still there. 4 student. So I throw away my x, I replace that with negative x. The power still there. Okay. Minus, I throw away my x and replace that with negative x. Everybody see that? Okay. Now we have to simplify this. Now we simplify this. Number 4 still there, yes. Negative x raised to the third power give you
Negative x. Raised
To the
to
negative x raised to the third power. Yes, so just negative x raised to the third power. Okay. Negative times negative becomes positive. Okay. Now you look at it, what I have here. Do you think that this is actually the opposite of this?
Yes.
Yes.
Yes. So I can write this is a negative of fx. Right? Because if you put a negative in front of each term here, you see, negative here, it gives you that, and negative here, it gives you positive. Okay? So this is equal to negative of fx. And we already showed that f of negative x equal to negative of fx. Then we can conclude this is our function. Okay. So if you calculate, in general, if you calculate f of negative x and it turned out to be the same, then even. If it turned out to be opposite of the original, then it's odd. Okay. There's some function. Even after you check, this neither even nor is it odd. Okay? If you have that case, you're in that situation, you just need to put neither. So maybe in your extra credit, there's some function. Okay? There's a function, and after you check f of negative x, you replace x with negative x. It doesn't turn out to be the same, nor does it turn out to be opposite. Then you can conclude it's neither. Alright? Okay. Any other question? Good? You just need to practice, do a lot of practice, and it should be okay. Okay. So that is the even and odd property of the function. There are a few more properties we need to take a look. Another one, we call that monotone monotonicity, because we want to check if the function is increasing or decreasing over a certain interval of the domain or not. Let's go back to our linear function. When you learn linear function, you look at the slope, right? And if the slope is positive, what happens to the line?
Goes up.
It's going up. It's increasing. Okay? If the slope is positive, it kind of goes like this. Okay. And if the slope is negative, it will be
Going down.
down. Okay. So if the slope is positive, the line is increasing from negative infinity to positive infinity. So it's increasing for on the whole domain. Okay. The same thing over here. If the slope is negative, it's decreasing from negative infinity to positive infinity. But that is when we talk about linear function. What if a function that is not linear? What is happening to that? For example, something like this. This is non-linear. This is non-linear because it's not a line. Okay? Then how do we check if a function is increasing or decreasing? Okay? So the concept of increasing or decreasing, we call that, so on the second part of our lecture today, we call that monotonicity. I'm going to write over here, just increasing and decreasing interval. So at this level, college algebra, in order to check if the function is increasing or decreasing, all you need to do is you have to graph the function, okay, and look at the part of the domain where it's going up and the part of the domain where it's going down, okay. Let's take a look at increasing first. I have the graph, the curve that look like this. Of course, by your observation, you see right away this is increasing, right? It's kind of going up. You know, we know right away it's increasing. Okay, let me call the value here, the point here, x1. Over here is x2. And the output here is fx1. Over here, fx2. Okay. Now anyone can tell me between x1 and x2, which one is greater? x2. Because x2 on the right hand side. Right. How about between fx1 and fx2, which one is greater? Which one?
FX2.
fx2, of course. Because fx2 is higher, right? So if we have x1 less than x2, and this implies fx1 less than fx2. Then we can conclude fx is increasing, okay, on certain part of the domain. The reason I say it's just on certain part of the domain because sometimes some function as part of the domain is increasing, the other part is not increasing. The other part it might be decreasing. Okay, sometimes it's not increasing nor is it decreasing. Okay, I'm gonna give you an example and you're gonna work on that soon. Okay. So if I look at this function here. Cubic function, you know right away that this is increasing from negative infinity to positive infinity. Okay, it's always going up, right? If we scan from left to right, it's like you start climbing the mountain and you keep climbing up. Okay, so we know that's increasing from negative infinity to positive infinity. Right. How about decreasing? Decreasing. Okay, I have a graph that looks like this. Well, you know right away by your observation, this curve is decreasing. And I say this is x2. I say this is x1. And the output here is fx1. And the output here is fx2. Again, if you compare x1 and x2, I know x2 is greater, right? And if you compare fx1 and fx2, fx1 is greater. Okay? So if x1 less than x2, and this is imply fx1 greater than fx2. So you see the difference? This is less than, but this is less than, greater than. Okay? Then fx is decreasing on certain part of domain. Alright. Example. Let's take a look at example. It should be alright. It's not really that bad. Because for this concept, all you have to do is you look at the graph of the function. Okay. I have the graph. I have a function whose graph looks like this. Okay. Something like this. And I say the value here is 1, over here is 3, here is 6, this is 9, this is 13, this is 14. And the question is, find increasing and decreasing interval. Okay. Answer. So you look at the graph, okay? If you look at the graph, do you think that the graph I have on my whiteboard represent function?
Yeah.
Yeah. Why? How? How do you know that?
Vertical.
Vertical line test. Very good. Vertical line test. Because if you apply vertical line test and you start scaling, and you will see that it cut the function at one point already. So I know that this graph represents a function. I don't know what function, but I know it represents a function. So as long as I know it represents a function, then of course we can find domain, domain range, we can find increasing and decreasing interval. Alright, let's find increasing interval first. Alright, so let's start scaling from left to right. Okay, you always go from left to right. Okay. So you started from here, right? You started from here. Okay. And you draw the arrow. Okay. And you see that it looks like this is going down, right? It's going down until you hit 3. So you start from 0, you go down to 3. Okay. This is increasing or decreasing?
Decrease.
That's decreasing. So increasing will be what? From where? From 3 to 6. So we're going to put 3, 6. Union with. Okay. Any other part is increasing?
9 to 13.
9 to 13. Everybody see that?
And 14 to
And 14 to infinity, yes. Everybody see from 9 to 13 is going up? See that? Here, up, going up, right? So this one going up, this is another going up. And from 14, oh, I have the arrow going up already. So 14 to infinity is going up. The reason we have infinity because this arrow. Okay? If I have this arrow, it means it keep expanding to infinity. Everybody see that? So I can write 9 to 13. Union with, because we're talking about interval. That's why we have to use union. 14 to positive. That's for increase. How about decrease? Same thing. So anyone can tell me where's it decreasing?
0 to 3.
0 to 3. 0 to 3. Union with
6 to 9.
6 to 9. And
13 to 14.
13 to 14. Very good. Everybody see that? So if you notice, you see that I always use parentheses. I always use parentheses. So that is what you need to remember. Every time you write interval notation for increasing and decreasing, not ever use bracket. Okay? Don't ever use bracket. So I'm going to put a remark over here. No matter what, it's an open circle or the dot circle or whatever, don't ever use square bracket when you write interval of increasing and decreasing. Never use square bracket. Okay. When writing increasing and decreasing interval. You know, I know that I'm writing like this, and I know there's something. Yes, you guys write it down, but believe me, on the test, someone will commit the mistake. Someone will put a freaking bracket on my interval of decreasing and decreasing. Believe me. This is the mistake a lot of students commit. Okay? So try not to. Okay? Try not to. Never. Even though that I have a dot here, even though that I have an open dot here, just use parentheses. Never use closed bracket. Okay? Never. Alright. So I give you another example. And I want you to get together. So go ahead, get to the group of maybe, can you move over there? You want to work with them, 3 of there, and go ahead and turn around here. So 3 of you, and move in here. And 3 of you over there. You can join over there, Jamet. Okay, you can join over there. I'm going to give you a function, a graph. And I want you to state the increasing and decreasing, okay? I want you to discuss together with each other.
He puts you with that.
Okay, something like this. Okay, so here is 2, over here is 3, over here is 5, over here is 7. Over here is 15. Okay. Over here is -2. So I want you to find increasing interval and decreasing interval. All right, go ahead. Go ahead, talk to each other. person, you can join them. 1, 2, and 3 over here. Okay. 3 here. That's group of 4 there. So this is a typical example of what we have on the test. So make sure you know how to write increasing and decreasing interval. Okay. All right. Go ahead. Discuss. We have about maybe 10 minutes. Then I'll go ahead and fix the problem for you. I'll be back. Talk to each other, guys.
Which one are you doing first?
I started with decreasing.
This is increasing, and that's decreasing.
That wouldn't be negative for negative 2?
For negative, that's
negative 2?
like negative
The first one?
2 without
For
decrease.
decreasing?
Well,
No,
because
negative
it's
two
from
is
0 to
decreasing.
2, it's increasing.
It keeps
I thought you
Control is which one?
Oh.
it keeps decreasing from negative 2 to 0. So you don't have to
It's decreasing.
Oh.
Yeah.
So do we even
Oh no, hold on, you got it wrong. There's 1 point that you're missing. And I'm gonna cheat over here,
it's an open circle.
because you're missing this point that you need to write down over here.
0, 0, 5 to 7, and 7 to 50.
So over here, 2 and 0 is decreasing, that's why it goes to
Oh, so it
increasing.
starts on 0 to
So negative. But I would say basically, yeah, so here is increasing basically on negative infinity,
15.
the other way around.
Yep.
See what I'm saying? Yeah.
Keep talking, guys. Keep
It's one of
talking.
those tricky ones.
You would jump straight to 15.
Yeah, for sure.
It's 5 to 15, not 5 to 7.
Yeah, because for 7 to 15, it's also decreasing.
The increasing is from 0 to
Negative 2.
Yeah, it starts at 0.
That'd be negative.
That'd be 0. Because then from 2 increases.
Increasing would be negative 2.
So that technically.
That'll be decreasing actually. That'll be decreasing negative infinity to 0 will be equal to 2, negative 2, and then 7, and then 1.
I don't think anything else.
So now it's negative infinity would be
Because it's all those circle, you gotta be sure.
5 and 7,
0
0,
is just taking away. If we don't finish with 2 and negative 2, that's where we start.
So I have 0 to 2, and 2 to 3, and 3 to 7.
because that will technically your.
And then the decrease is,
negative 2 to 0.
negative 2 to.
Did he pass this on in the beginning of class?
Maybe negative 2 to negative.
I guess he can go either way. He can count it
Oh,
all.
2 to 0.
I guess he can be,
Increasing.
because he didn't list it technically.
So if you finish that, I want you to discuss this another one. Okay. Same thing, by increasing and decreasing.
How? This says 4, then 8 and 7.
Yeah,
Keep
so I was
talking,
just looking
guys. I
at
want to hear some noise.
goes from 8 to 7.
You're talking.
Wait, so the increasing the draw will get to.
Negative,
Mm.
then you get put the
Yes. I
I
would.
Oh, and 15 to negative infinity.
It's funny because I was gonna fall for it.
Yeah, I almost fell for it.
Oh, that's the error. So
Okay.
basically, that was, infinity was a trick.
And I wrote it down.
Everybody got a the first one?
So what, yeah, so what is that one over there after the 8, between the 8 and 11?
Because here
It just go down from there, go down.
Also, it doesn't go down that point over there?
So I
That's,
think we don't.
that's
do
a,
it.
yeah,
goes
it's
from,
go horizontally, they go down.
Then
Okay.
for
So there's a
example,
point.
eight,
It's
do
still
you
there.
want
No,
to
I know that, but
then
before that,
increasing
it's
from
not,
eight to-
Before you be over here,
that corner in there. That
right
one.
here,
On the left, the left one.
Oh, that's
left
11.
right here,
Yeah, that one.
that's a point.
No.
Yeah, but what is it?
Well, he
Oh!
doesn't.
Oh, yes, 10.
Okay.
Oh, that's a 10. Then we're-
So let me fix this first before you jump into that, okay? So anyone can tell me where's the increasing over here?
I had a question on that one first. Is that increasing -2 to negative infinity?
-2, 2.
Negative infinity or no? It's because you go the other way around.
-2 to negative 2
Well,
to
you put
infinity.
you put the arrow keep going up, so I just.
This is, yeah, the arrows keep going up, but you always go from left to right, remember? You always go from left to right. I give you a couple more minutes.
That was my only
Okay,
question. So
okay,
if not,
alright.
this is.
Alright, so let's jump. Let's go from left to right. It's like you climb it, even though the arrow, this arrow here doesn't mean that you go this way.
Okay.
This arrow here means that
Negative
it's
infinity.
extending.
Okay.
Okay, it extends to this way and this way. It doesn't mean that you're going up. You always go from left to right.
Right.
Okay? So if you go from left to right, go down, right? So it's decreasing from negative infinity to
0.
0. Okay? Then you start climbing up. From 0 to
3.
3. 0 to 3.
Hard.
Alright. Then you climb down. 3 to 5. Then you climb up. 5 to
15.
15.
5 to 15. Very good. You can split them up. 5 to 7, then 7 to 15. That's 5. Okay? Then you start climbing down from
15
To
to infinity.
infinity. Alright, so that's the answer for that. Go ahead and discuss the second example.
Even though it's going down, it's pretty on the
When there's an arrow, that
Doesn't
means it keeps going down.
But he just said it was.
If we talk about the domain, yes, we don't want to include that in the domain. But this is increasing and decreasing.
-2 was.
That's why I say that the domain is an open circle or closed. You just use parentheses.
X-axis.
That's what I was.
So
It's not to the
it goes
right.
to infinity.
Because we talked about
X-axis.
increasing and decreasing.
So 5 to 7 or 5 to 15?
5 to the same.
Yeah, we
Oh,
It's 7.
More than 8.
7 is this is 7 and that's 8.
It's it.
I just wrote 7, 8.
You can split it up 5 to 7 and 7 to 15. That's 5. You can jump from 5 to 15. That's okay. Because we don't talk about domain. If you talk about domain, yes. But this is increasing.
So I can put 0 to 2?
At 0 to 2.
Or no, because it's on increase, they just say.
Yeah, you keep. Yeah, it keeps increasing until 3. You know. So you cannot say from 0 to 2. 0 to 2 is increasing.
Yeah.
But you have to do another part 2 to 3 if you want to do like that.
Okay.
Otherwise, you just go right 0 to 3. It's much
That's what
easier.
I did.
You do 0 to 2 and 2 to 3.
And then 5.
That's fine.
That's fine.
That's what I mean. Yeah. That's why you have this.
Yeah.
Understand it?
I don't think it would. That's not gonna be
Yeah, basically he's saying take for.
Yeah, so.
Okay, go ahead and discuss the second example, guys.
And then why would it be
Like
negative
4 to 7.
infinity to negative 0?
Negative infinity to.
And the first one for me.
You can do that. Negative infinity to negative 2 and then negative 2 to 0.
Yeah.
Same. Yeah, as long as you have the letter U.
It's fine to me.
Yeah, it'd be 8.
No, you're
If you want to
fine.
split it up like that, it just take more time to write.
Yeah, you can go to a straight line because it's not an increase or decrease.
Can you explain why this is 8 and that's 7?
Yeah, 11 to 10.
Because it's on the x-axis.
I understand now. I understand.
Just put two dots.
I thought when you put the 70 out there, he was like,
So why?
Is the group over there is okay? Any questions?
The first
Good?
one I was
Good?
Yeah,
Easy,
this is-
right?
it makes so much more sense.
This is lined up with 7.
I was literally just nodding with you guys. Like, you said, get it? No, I didn't.
You have to replace that, okay?
So you, all you're doing is replacing.
Does he
Replace-
like-
oh, yeah.
These are all the gaps, so that we're only gonna be adding.
If it is same, if it is turned out, if you replace the action, if it turns out to be the same, then you know it's even. If it is opposite, then it's off. But if it's neither, no, it's not even, it's not the same, nor is it opposite,
You know,
then you wouldn't be having.
But what if you gave us a negative inside of?
So basically he's saying that,
You mean negative here?
Yeah, what if you already gave us, and then we would put a positive, or would that?
No, we don't, we never had that, we never had that, we always have like this. Yeah, we never have negative accents.
I think we could have a 12 there.
You
so
read
that 11 will
History.
fall in the middle.
Alright.
Just never read Arabic.
Everybody got a second example?
Yeah.
You went to.
All right.
school,
Let's do another one.
Arabic school, at home.
Oh, no.
Same thing as alright, let's do this. Increasing.
That's not too bad.
Anyone can tell me where it's increasing?
0, 4.
0, 4?
8 to 10.
8 to 10. Union. 8 to 10. Then that's it, right?
Yeah.
How about decreasing?
7 to 8.
7 to 8.
7 to 8.
Union.
Union.
11 to
11 to infinity.
Oh.
How about between 4 and 7?
He's gone.
Oh, increase or decrease.
It's neither increase or decrease. So if I ask you where the part of the domain, the function is constant, you're gonna write 4 to 7.
And then 10 to 11.
Yes. Oh my God, this is so easy.
That's
Too
how it
easy,
says- that's how it
guys.
says
Come
on
on. Even the sixth grade know how to do this.
Let's have a test on it.
They just look at the graph and you know, oh, come on.
Is this
So
all that's
easy.
on the second test?
So you see that the graph over here I
it's
have
scary.
here, we don't have
So you get 100% on?
we don't have constant. We don't have constant interval here. So only that part has constant.
The graph is gonna be
All
like.
right. Any other question here?
Increasing, decreasing will be very nice.
Very good, guy. Okay. So you see that. Let's continue with our lecture. You see that. If the function is increasing and decreasing, and sometimes it's constant, and sometimes it more interval of increasing than interval of decreasing, it will create hills and valley, right? So you see that it's like this is a valley and it's a hill and a valley, something like that. Okay. And when it creates hill and valley, it gives you a highest point and a lowest point. Okay. The highest point in mathematics we call it the maximum point, and the lowest point we call that minimum point. Okay. But there are two different types of maximum and minimum. So on the third part, I'm going to write it here. I want to talk about maximum and minimum. Minimum point of the function. So there are different types of maximum and minimum. The first type is the absolute max min. So we need to know what is absolute max. What is absolute min? Okay. They have an official definition for that. But with my experience, I just think that if I go through the theory too much, you guys probably, it's hard for you guys to understand. So I'm not going to give you the definition, but I show you how to find absolute max and absolute min, so that on the test you know how to do it. Okay? So what is absolute max and absolute min? When I this word absolute, absolute. It means the highest point, right? And it doesn't matter if we have hills or we have valley. As long as you can see the highest point of the function, that will be the absolute. Okay? Let me go straight to the example. I have a function like this. Okay, let's draw another function with me. I have, again, I can have something like this. Stop here. Okay, there's no arrow, it means stop there. Extend it. And open circle here. There's no arrow here. So I have the value, the coordinate here is -1, and here is 6. -6. Over here is 1, over here is 2, here is 3, here is 4, okay. And here I have coordinate is 8, and this one is 8 here, so this is around 6. So we just learned how to find absolute maximum. Okay, we don't care about the definition in this case anymore. It's more confusing if we talk about definition. Because in definition, actually, if you're really interested in mathematics, and you see that definition again in a very high advanced level of math, which is you don't need, in my opinion. Okay. So I want to find, question, I want to find absolute max and min point of the function. Answer. Okay. Now you look at the graph. Can you tell me which one is the highest point of the graph?
6 or 8?
6, 8. The coordinate. So every time they ask you the point, absolute max and min point, okay, you have to write it in order pair. And Stephen just told me that the point, the highest point here, the coordinate is 8 and 6. So absolute max will be 8, 6. 8, 6. So this is order pair, okay? This is not interval. Max. Coordinate x component 8, 6. Which one is absolute mean? -1, -6, because that's the lowest point. Okay? It's absolute mean. -1. -6. Oh my God, this is too easy, guys. Come on. Just look at the graph. Oh my God. So easy. Okay? So everybody clear with absolute maximum. Okay? Now, let's consider, on the second part, let's take a look at, we have another type of maximum. We call that relative max mean. So what is relative and what is absolute? What's the difference between those? We're going to tell the difference. We learn how to tell the difference between these two concepts. Okay? And I'm going to use the same graph. Okay? I'm going to use the same graph. Question: find relative max mean point. Answer. So, relative max, you look at this way. is the top of the hill. Relative means is the bottom of the valley. Where is the hill?
2, 2, 2.
This is the hill, right? So this is the top of the hill. So the coordinate here will be
2,
2, 2. So this is relative max. 2, 2. Where is the bottom of the valley?
-2, 4.
4,
Oh,
-2.
sorry.
Relative mean. 4 negative. Okay. So remember, so I put a remark here. Okay. So relative max is top of the hills. We probably have a lot of hills. You know, in this graph we have only one hill. Okay. And relative mean is bottom of the valley. It's the bottom of the valley. It's much easier for you to understand like that. Okay. However, sometimes the relative max is also the absolute max. For example, if I look at this graph, oh, let me see, probably, no, I cannot use that. I have the function that looks like this. I have 1 hill, 2 hill. How many values we have here? 1 value. Okay, so this is, let me see, this is 2, this is 4, 4, this is 5, this is 6, 6 -1 level, this is 8, and this is 6. Okay. How many hills we have here? 2 hills. We have 2 hills. Okay, right here and right here. Okay. So if we have 2 hills, we have 2 relative max. We have 2 relative max. So relative max here will be, what is the coordinate of the hill? Top of the hill.
6, 8, 6.
8, 6. Okay, and 4, 4. Don't use union, okay? Because this is a point. We don't use union. Okay. How about relative means?
6, -1.
6, -1, because that's the bottom of the valley. Yeah, 6, -1. Now I'm going to ask you, what is the absolute max?
It's 8, 6.
Okay, she said it's A6. Everybody agree with that?
Yeah.
Put down both.
The highest point,
For the
right?
max.
Okay. Go back to the definition, our old definition of absolute. Absolute max is the highest point of the function. Which one is the highest one? A6. So we have only one absolute max, A6. And you see that? In this case, absolute max and relative max is the same. Yes.
You can have 2 relative max though?
If they're the same height, maybe yes.
We do have 2 relative max.
How?
No, but I'm talking about, for example, what if
Top of each hill.
what if the first one
8, 6 is
will
a
be
higher max.
4, 6 as high as the other one?
Yeah,
we
but
have
because-
both.
Oh, yes.
Okay.
Yes.
Absolute height.
If the function is moving up like this, you mean like this?
Yes.
I'm not-
Then we do have 2 relative max, 2 absolute max. Yes. Yes. Okay? But I mean, that barely. Okay? So in this case, you see this absolute max is the highest point with A6. Yes.
On the first one, is
Okay.
that second where it goes up? Is that considered a hill even though it doesn't finish all the way going back
Because
up?
I stopped right here.
Yeah, is it still considered a hill? Or
No, no hill.
Okay.
Then how do I know it's a hill?
Because it does decrease.
Yes, it's increase and decrease. Come on, it's
Okay.
a
Just check.
hill, right? A hill, come on, a hill. What a hill means? We have to go back to English. It's a hill.
Just checking.
What's it valley? This is valley. Silicon Valley. I don't know it look like this or not. I never been to California. Okay, so this is not a hill. This is a hill. This is valley. Okay, so we have two hills, one valley. The next question. What is absolute mean?
Wouldn't it be the negative?
Negative.
Negative infinity?
Oh, yeah.
Well, but it's not a point.
It's not, that's not a.
Then is it
There is
6
none.
minus?
There's none. Okay, someone agree with that, or is
It's
anybody
only
else?
one.
Negative
It's only one. 6 negative 1.
6
6 negative 1 is absolute mean?
Yeah.
No, because.
I
Okay, let's go back to the definition of absolute mean. Absolute mean
Is the lowest point.
It's the lowest.
is
point.
the lowest point.
What, is it negative infinity?
Do you think second 1 is the lowest point?
No, because the
So
arrow
this
is
and
going.
Because the arrow going
I'm looking at the
down.
body. I'm looking at the body.
Because
Yeah,
the arrow going down. And we cannot
Yeah.
define absolute mean because it keep going down. I don't know where it goes. Go to hell maybe. Okay? We don't have it. None.
Oh, no.
We don't have it. Okay? Everybody clear? I'm going to give you another graph. We have 10 minutes. I'm going to make a graph. And you're going to work on a problem. Yes.
What if one of the arrows was a point?
What if one arrow? Let's see.
It would still be.
Okay, let's see. Let's see. What if this over here stop here? Okay, which one you want to ask?
Absolute min.
Absolute mean? Absolute mean.
But
The arrow's still going down. We still don't have it.
Both of them have to be points.
But do you think that this point is relative mean?
No.
No.
No, because is this the bottom of the valley?
No,
No,
it's not curved.
it's not the bottom of the valley.
So this be.
It's not the bottom of the valley. It's not relative mean.
Ask him.
I'm not asking.
Ask me.
You know what like a
Like a
candy
hook.
cane looks like? Yeah, a hook. Would that be a hill if it went like this and the stop right here?
You mean like that?
Yeah. Is that a hill?
Right here?
Yes.
It is.
Okay.
It is. It is a
Okay,
hill.
as long as
It's the-
But if it's just like that, no hill. Because you don't go down.
But there's a
Look,
valley.
come on. You guys don't have the definition of the hill. This is a hill, guys. This is a hill. Hill. Valley. Okay.
That's not really good.
So if you climb it up, and you climb down, if you climb up and you stop right there, you cannot climb down, then it's not a hill. Jump. I know. Clip or somewhere, yeah, there's a clip, or maybe, yeah. Okay? Alright, let me give you the example, guys. Let's practice. Let's see.
But you can fall down if you want. It needs to be a straight drop down.
So what's the?
Alright, let's do this.
Absolute minimax is.
So I want, for this problem, I want you to state relative max, relative means, absolute max, absolute mean. I also want you to state domain and range of the function. This is my function. Alright. So here, 2, 0, 1, 2. Okay, over here
You know what? You know what the
3 over
You go on
here.
the treadmill.
Basically, just two.
So
I don't
5,
feel like
6.
Oh, I
Okay.
stopped.
8. Over here is negative 2. Over here is 2. Over here is 4. Over here is 6. This is 9. This is 13. This is also 2. 14. 16. Over here 17.
How about the body? 15? The bottom of the body?
The bottom of right here, okay, the bottom of right here. Let's make it a little bit longer. Here you go. So you have the bottom of that is negative 3. Here you go. Go ahead, state max, mean, relative. Max, relative means domain and range.
I'm not gonna draw it.
Go ahead, guys. Get together, guys. Yes.
What's the max and min of something with a constant? Like the example right to the left?
Right here?
No,
It's gonna be on
like the red one.
The red one?
For, like,
Oh, right here?
Yeah.
Okay, what do you think?
It would be.
Would you use a union on max and min? Like
Do we have max and min here? You guys talk about absolute max, right?
Yeah.
Okay.
Oh, so absolute
no,
max
because
is only
there's no
1
hill.
point.
It's a point.
Okay,
So
so there
the-
is none.
11, probably like, I don't know. 8.
There's none.
But like
That's a very good question.
there's none for all of them, or
No, max,
like relative too though, because like do those
You just
count
need
as
to
hills?
state one.
Just one in that in the space
So,
of 4 to 7.
5,
Yeah.
6 is not considered a point? Because it's not a hill.
So like I
5,
could
6
state
is not
like
considered a point?
You can state
It could
10
be
and whatever
absolute,
here.
It can't
Okay.
be
Yeah.
and
relative.
then I could state like 5 and whatever though,
5? No, because it's lower.
for relative though.
or like relative.
For relative, this is not, for relative, this is not, it's not a hill, guys. Because
It
we're
has to
going
be
horizontally, it's not a hill.
Okay, even if there's a constant in between, it doesn't.
So over here it's not relative because it's going up, but it's going horizontal, it's not a hill.
Okay.
Look at this picture again.
It's just like a big
What
hill,
is
you
it?
know?
Is it going up and down? Is it going up and down?
Yes,
No, it's going up and you go like that.
and then down.
It's not going down. This is not a hill. No.
So what do we have for this?
Over here?
Min.
We don't have
It's
anything.
this one right here, right? Yes. What's the first?
But we do have relatively.
Is it four?
This is the bottom of the valley, right?
Not sure, right? Yeah, so each one, this is the most.
Alright, go ahead. Come on, guys. We have 5 minutes. Get together. Go ahead and do this. Oh, it's take time for you to draw it?
Yeah.
I'm just looking at the board,
Okay, so absolute
just take a
max
picture
is-
and then just do it.
It's like one of those
5, 6.
little website games you make the roller coaster.
What's that?
It's like roller coaster type.
What's that?
No, to the left.
I was a
Like
little
graphics
advanced
and-
and
Is.
catch on to that, so.
Is
Just
that
take a picture, I just draw it right on, just do the
Rockets,
exercise first.
that's all I got.
Where it's supposed to meet with this one?
Negative 2, -1.
What's that?
That's the point over here, the first one. On the whole
That's
graph.
I bet you see one
No, the whole
or
graph, the
two
whole graph.
questions on our
The
side.
first one on -2 from the
The rest
X,
will be everything
Right.
hard that we
what's
learned.
Right here?
that? Yeah, no, the first one.
Right here?
No.
Negative 2. Oh, very good. Negative 2, negative 1.
Be enough to get me a 20 on my
Yeah. We got 2 minutes.
So,
Change something, because he's gonna screw us up a little bit.
So is that 13 and a half?
Why is that? You changed my number?
Yeah, because of these.
Oh.
Okay, good.
Smart. Smart.
Yeah.
Oh, wait.
Big brain.
Let me ask you, what is the domain of this?
Negative 2 to 17.
Negative 2 to 17?
like -2 to 12.
Aha, right here, the circle. undefined. Negative 2 to 12.
Then
You
12
did
to
what?
17.
12 to 17. Yeah. How about range?
Negative 3 to 6.
Negative 3 to 6. Negative 3 to 6. Okay. Because it's still defined at y. Alright, so go ahead and take a picture. Have fun at home. You guys have any question? Bring it back to me next time. Next week, okay? Alright guys, if you guys have not get a